Hey everyone, welcome to Unit 1, Day 12. Today what we're going to talk about is the function and its definition, right? We've been talking about functions for quite some time now. Like we know how to graph them, we know how to evaluate them, we know how to read them from story problems and many other things, but we've actually never talked about what the technical definition of a function is. Like, what is it? And that's what we're gonna talk about today. We're also going to learn what that definition means for a table, and then we're going to identify tables that represent a function and those that don't, so that we can see the difference. All right. Today's review. All right, we're going to work on describing a graph. Right, so this is not something that's going to go away. We're going to be seeing graphs all throughout Algebra 1. You'll see them again in Algebra 2. So we've got to be able to describe a graph and identify the important parts of a graph. So it's a good thing to go over for today's review. All right, so you might remember a problem similar to this on last week's test where we are given a function and our job is to find these important points, the x-intercepts, y-intercepts, minimum, maximum, and the line of symmetry. All right. So let's start with the x-intercepts. So remember, the x-axis is the horizontal line that runs through the middle of the graph here. So this is our x-axis down here, and we're looking for where the function touches or crosses over that x-axis, and we can see that happening here and in another location over here at -2. Right, so those are the two x-intercepts that we have for this graph, and I'm going to describe them both. Okay, so I'm going to say the first one there is at -2, comma 0. Now remember, this is a point on a coordinate plane, so we have to make sure that we describe it using a coordinate just like this, x comma y complete with a set of parentheses. Okay, and then I'm going to put a comma here, and I'm going to write the second x-intercept, which occurs at 4 comma 0. Okay, so when you go to MyOpenMath and you do a problem like this, you're going to make sure that you enter in the first coordinate, second coordinate for the x-intercepts, and then you will put a comma to separate the two. That's if there are two. All right. Okay, so y-intercepts, very much the same type of concept, except we're looking at the vertical line that runs through the middle of the graph. So we're looking for where the blue function touches or crosses over the y-axis, which is going to happen right here. There we go. So that location, right, it's also a coordinate, so I need to make sure I have an x comma y complete with a set of parentheses here. So I'm going to say 0 comma -2. Okay. Now minimum. Minimum is the lowest point on the graph. Okay, so if I were to treat this like a roller coaster and I ride the roller coaster, I'm going to go down, 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 and then I get to this point and it starts to go back up. So the lowest point that this roller coaster gets to is located right here. So this is a minimum. Okay, and it has a location. So it is located at 1, -3, right? So I go right 1, down 3 to get to that point. So I'm going to say 1 comma -3 is where the minimum is located on the graph. Now a maximum would be the highest point, right? So if I were riding my roller coaster again, if I got on my function and I started riding this thing up, I get to this point and I see this arrow that's on the end, right? And this arrow tells me that the function keeps going forever and ever and ever. It actually never stops going up. So that means there is no maximum. We would simply say DNE. All right. The last thing they want us to find is the line of symmetry. And if you recall from previous lessons, the line of symmetry is the line where I would fold the graph in half, right? So I would fold it in half in such a way that one side of the graph is going to land on the other side of the graph. And it might not look like it at first because of where we're cut off at, right? Because our graph does cut off over here on the left and the right. It might look like this line is a bit longer than this line, and you might assume that there is no symmetry with this graph. But you have to remember, because of the arrows, it keeps going on forever and ever, right? So if I were to fold this thing, let's say right here, right? If I made my fold line here, okay, that means that the left side of the function would land perfectly on top of the right side of the function over here. So this does become a line of symmetry. And to describe a line of symmetry, we look for where the line of symmetry hits the x-axis. So this dashed line is my line of symmetry. It hits the x-axis here at 1, so it has an equation x equals 1, and that's how I describe the line of symmetry. And I need to make sure that I put it in as x equals 1, especially when I do it on my open math. Otherwise, it'll count it as wrong. Okay, so that's our review for today. Let's talk about the definition of a function, right? And I've typed it out for you here, and I'll read it out loud for you. It says a technical definition of a function is a relation from a set of inputs to a possible set of outputs, where each input is related to exactly one output. Okay, so if you can think, right, there's a set of numbers, right, we'll call them inputs, and then there's another set of numbers which we'll call outputs, all right, and each input is related to an output, but only one output. So every number that's an input has exactly one output. All right, so let me give you an example of this, what this looks like conceptually, maybe a little bit more of a visual representation of that definition. Let's say in this bubble, I'm going to put some inputs, just numbers, okay? So I'm going to say these are the inputs. I didn't even spell that right. So there's my inputs, and over here in this bubble, I'll put some outputs. Right, these are going to be outputs. All right, and we'll just put some numbers over here. Let's say 3, 7, and 12, right? So pretend there's a function, and the only inputs that this function has is 3, 7, and 12. These are the only inputs that we have. All right, and then over here we have some outputs. Let's say, I don't know, let's say 5, let's go 8, and let's do 14. Okay, so these are going to be outputs. Now, remember, our inputs over here, according to this definition, can only be related to one output. So let's say I have a function, I put a 3 in, and when I put a 3 in, I get an 8 out. That means 3 is related to 8, right? Because when I put the 3 into the function, I got the 8 out. So these two are linked, right? And let's say I do the same thing. This time I put a 7 in, and 7, when I put a 7 into the function, I get a 5 out. Okay, so this is just a hypothetical function. It doesn't matter what the rule is or anything. I'm just saying 7 goes to 5. And then by default here, 12 will go to 14. And this would represent a function because every input goes to exactly one output. All right, so let's try it again. Let's look at one that's not a function. Okay, so I have my inputs and I have my outputs here. Okay, and we'll use the same numbers. Let's do 3, 7, and 12. And over here, I'll put the same outputs, 5, 8, and 14. Okay, and let's say this time I put a 3 into the function, and it goes to 5. And it also goes to 8. Okay, and then we'll say that 7, maybe it goes to 14, and let's say 12 also goes to 14. Okay, now this would not be a function specifically because of what's happening here at 3. Remember, our definition says an input is related to exactly one output. But look at what happens here. 3 is related to 5, and 3 is related to 8. So it's like if I put a 3 into the function or into whatever this relationship is, I can't call it a function now, but if I put a 3 into whatever this machine is doing, I have no idea what I'm going to get. I'm going to get a 5, I can get an 8, I don't know which one I'm going to get. Okay, so this would be not a function. Okay. And that's because of the input going to two different outputs here. All right. Now, let's look at one more interesting situation here. All right, and again, we'll do the same thing here. These are going to be inputs, and these are going to be outputs. Okay, and let's do 3, 7, and 12. All right, and then we'll have an output over here. But let's say only one output this time. Let's do 11. Okay, so only one output. So what that would mean is that 3. I'm going to put 3 into the function, and I'm going to get an 11 out. And then I'm going to put 7 into the function, and I'm going to get an 11 out. And I'm going to put 12 into the function, and I'm going to get 11 out. All right? So no matter what I put into the function, it doesn't matter what number I put in, I'm always going to get out an 11. The question is that a function? And if we think about our definition, right? So I'm going to go back up here and just look at my definition for a second, right? It says Each input is related to exactly one output. Each input has one output. So here's an input, and I go over here and I look, well, it's only going to one output, right? 3 goes to 11. It doesn't go to anything else. So that input has one output. And then 7, right? 7 goes to 11. It only goes to 11. So this input also only has one output. And then same thing here, 12 only goes to 11. It doesn't go to anything else. So this input also only has one output. So even though every single input goes to the same thing, it's still a function. Okay. So those are some good demonstrations to help you understand what that definition of a function means, right? We're really looking for each input to have exactly one output. And so how do we use this with the representations that we've been using, right? Because we've never seen these bubble type representations before. We've seen tables, we've seen graphs, we've seen equations. So today what we're going to focus on is, well, how do I identify whether or not something is a function just by looking at the table? All right, so let's take a look at this one. This is a table, right? We have all of our x values here in the first row, and then f of x, which is the same thing as y, representing all of our all of the numbers here in the second row. And you have to remember x represents inputs, and the y, or the f of x, represents our outputs. Okay, and so we learned about this way back in week 1. Right, so these are inputs up here. These are the outputs down here. And so this is telling me, like, when I put a 0 into whatever this potential function is, I get a 1 out. Right, 0 goes in, 1 comes out. 2 goes in, 2 goes out. 4 goes in, 3 comes out. All right, and what we're looking for is any situation where any particular number produces 2 different numbers. Okay, so 0 goes to 1. Right, so right now 0, the input of 0 has one output, and it is 1. And I might go through the table and I don't see another 0. So 0 right now, based on what I can see in this table, only goes to one output. Okay, so same thing for 2, right? 2 goes to 2. I don't see 2 pop up again in that first row, so as far as I can tell, 2 only goes to one output. Now 4 goes to 3, right? So 4, put a 4 into the function, 3 comes out, and I look through my table, and here's another 4 over here, and this time it goes to 9. So when I look at this, here 4 goes to 3, and over here 4 goes to 9. This is not a function, because I have an input, right? This input of 4 goes to 2 different numbers. Can't have that, so it's not a function. Okay, so let's try it again. All right, so I got another table here. I want to try and figure out if it's a function. Sure, no problem. So let's see, 0 goes to 3. I don't see 0 again. I just start looking. So really, you might have picked up on it in the first one. What we're looking for is if there's any repeat numbers in that first row. Okay, so I see 2, right? So I see 2 happening twice, and I look at it. 2 goes to 9, and over here 2 goes to 9. So we're good, right? Even though 2 appeared twice in the table, 2 goes to the same exact number each time, right? So 2 is only going to one output, and I don't see anything else going to more than one number. So this is a function, as far as I can tell, based on what I see in the table. All right, last one here that we'll take a look at. Okay, you might notice something peculiar about this table, in that all of the outputs are the same, right? Everything is a 9. Right, in the y column here. So 0 goes to 9, 1 goes to 9, 2 goes to 9, 3 goes to 9. And the question is whether or not this is a function, and it is a function. Right, this is much like that last bubble situation that we looked at, where every single input goes to the same number, but it's still only going to one number. Right, 0 only goes to 9. It doesn't go to anything else. 1 goes to 9. It doesn't go to anything else. So that's one input, one output, and that's what we're looking for. All right, guys, that's it for today's lesson. You should give the daily practice problems a try. Let me know if you have questions in the Zoom chat. Have a great day.